All right, everyone, welcome to this week's presentation from DBA Fundamentals, Intro to Spark for SQL Pros. This week's presenter is Warner Chaves. Today is December 13th, 2022. And this is us. On the top right-hand corner of the screen, you'll be able to see, let me make sure, in the top right-hand corner of the screen, you'll be able to see our three leaders of the DBA Fundamentals group, Cancel, Shane O'Neill, and myself, Kevin Wilkie. Below that, you'll see our many ways you can get to us in social media. Obviously, the first one is Meetup, where you probably saw most of us and saw most of the links to get here. So with that, please be sure to give that out to as many people as you can who you think would be interested in the stuff we present. We've got lots of great presentations coming up over the next year or so. All right, so below that, you'll see our website, dbafund.org, which is where all of our past presentations and future presentations are. So be sure to go out there for that so you can see all of our upcoming presentations. Also below that, you'll find our version of YouTube, dbafuntube.com. As one of my friends have said, it is the best place for DBA on the web, because you'll learn all of this great stuff from presentations that we've had. When you're there, be sure to like and subscribe to DBA FunTube, just so you'll know when our presentations go live and are on the website. Below that, you'll find our Twitter, our Slack, and our LinkedIn groups where things get posted from time to time. As with that, like I said earlier, all sessions are being recorded and usually be available within 1 to 2 days. Check us out on dbafuntube.com. And with that, remember to turn off your video and mute yourself so that we can all focus on Warner as he gives our great presentation. I'll be actually going off camera here in just a minute. Please be sure to type any questions you have in our chat window and we'll feed them off to Warner, or he can read them off as he feels like as time goes on. And so with that, we have Warner's bio, but that I am sure Warner will give a much better one when it comes up to him. So with that, Warner, my friend, I'll turn it over to you. I will go black, and now you should be able to share as you like. Start your wonderful presentation.
Thank you so much, Kevin. And hello, everybody. Hopefully, everybody's having a good day wherever you might be in the world right now. I am in the Eastern time zone, and I'm going to start sharing. So let me start going with this. Let's do. Hopefully, you guys can see my PowerPoint.
Yes, we can.
All right, so let's get going. So again, everybody, thank you for joining me today. I appreciate the time that you're spending to learn Introduction to Spark for SQL Pros. Allow me to introduce myself. My name is Warner Chaves. I am a DBA. Well, I was a DBA. I've mostly been a consultant, really, for the last few years. I've been doing it for 16 years now. I used to be a DBA at HP in Costa Rica. I'm actually now a solutions architect at a company that's called Pythian, based out of Ottawa, Ontario, in Canada. I am honored to be Microsoft Data Platform MVP. Feel free to reach out to me on my socials, whether it's Twitter at Warchaf, or check out the blog, createdatapros.com, or an email, warner@createdatapros.com. Or feel free also to just look me up by name on LinkedIn and connect. I love connecting with all the people that participate in my sessions as well. And we can, every now and then I get messages from people asking all kinds of things, from tech advice to career advice on LinkedIn as well. And I usually try to get back to everybody in a few days. All right. So the agenda is we're going to be doing an intro to Spark and demo some core functionality of the platform and a couple of the most popular ways that people run Spark today. This is 100% a beginner session. That's why it's an intro to Spark for SQL Pros. And my main objective with this session really was to demystify the whole big data, how some people thought, or some people still feel like it's kind of overwhelming, like there's a lot of information out there. And if I can just recommend people one way to just get going, get started, and add, the quote unquote big data check mark to your resume is to learn Spark. Okay. So we will go over Spark concepts and demos. There's a little bit of slides, not a lot. Then we'll do mostly demo time, and then we'll leave some time at the end for questions. All right. So prerequisites both for the session and for learning Spark, in my opinion. So basic experience working with databases and SQL, which probably all of you right now online have, and basic knowledge of what's data warehousing, what's ETL, what's big data, right? What's the just literally, to know the difference between working with an OLTP database or working with an analytics database, right? What is a data warehouse, right? What's ETL? That's just basic business intelligence kind of database concepts. And that's really all you need to know to follow the session today and to really learn Spark if you want to. So first, let's talk about the history of this product. So um, we're gonna rewind time here back to 2006. That's when Hadoop was released. Most of you are probably familiar with the term Hadoop. If you're not, then basically Hadoop was the first release from Apache to be able to do distributed map-reduced compute over storage, commodity storage. And nowadays, today, we think about this and it's like, well, who cares? Like anybody can do distributed queries because, Spark is here and we have all these other super easy to use cloud tools that allow us to do stuff like this. Like, if you're using Amazon, you have Redshift or Athena. We have Google BigQuery, we have Synapse, we have Snowflake, right? We have Databricks, which I will cover in a second here as well. But back in 2006, it was a big deal because companies that wanted to do compute and queries over a large amount of data were mostly using really expensive on-prem proprietary hardware and licenses. So we're talking about, the golden days of the Oracle data warehouse, the golden days of the Teradata appliances, right? So these were systems that just to get going, you would have to spend several millions of dollars of hardware and then several $1 million of licensing on top, right? So Hadoop came in and kind of like changed this paradigm because at least it was the first time where you could just build this type of system yourself with commodity hardware and with an open source package. The problem with Hadoop was that it was all over the place. So Hadoop required different modules for querying with like a SQL style syntax. It required different modules for running jobs on like Java or Scala. It had different ways to load data that were disconnected from like the other modules. So it was a hodgepodge of a bunch of different things. To attack this problem, but keeping the idea of, the distributed nature of a querying system, the Apache Foundation developed Spark. And version 1 of Spark was released in 2014. And the idea of Spark was to get rid of this like super fragmented ecosystem of poorly integrated tools and just have one place, just one package fully configured that had the capability of doing the schema on read, loading the data, writing the data back out, being able to do multiple languages in one, being able to do batch and streaming in one, and so on, right? So that was Spark v1 released in 2014. So if we think about it, Spark has been around for 8 years now, so it's not going anywhere anyway. The latest major release of Spark was V3 that was released in 2020, so a couple of years old by now. And the latest major sub-release is Spark 3.3, was actually released in just now June of this year. And this, like I said, is not going anywhere. Spark is widely used around the world, millions of users, tons of downloads, and it has a huge commercial ecosystem behind it now as well. So if somebody today wants to adopt Spark, they can be sure that it is not just going to disappear. The Spark architecture, just really quick. So we have a main node that runs a program. It's called the Spark context. And then this Spark context will communicate with a cluster manager package that then distributes work to different worker nodes. And the worker nodes run tasks. And the tasks are the actual parts that crunch numbers, right? They go out and they either look for local, remote, or cloud storage. They do some computations, and then they pass it right back into the main node. Sometimes it's called the driver node as well. And then from there, it sends the results back to the user, right? So it is a system that is by nature built to be distributed, right? The nice thing about Spark, or the value prop of Spark, is that these worker nodes, you can add more worker nodes and they partition automatically the work so that you can do compute over large amounts of storage. So what is the value prop, or why has Spark taken off really? Well, it's open source software and it's portable across platforms for the most part. So let's say if you develop a bunch of different Spark notebooks or jobs or ETLs on Azure, it should not be horrible. It's gonna take some work still, but should not be horrible to move them into Google Cloud. Obviously, you have to move your data too, right? So you have to repoint some folders and stuff like that, but the core amount, or the vast majority of the code itself, will not be um, just Azure code, or would not be just Google code. There's always some little bits of customization though, which I'll talk about in a little bit, but for the most part, it is portable. um, Spark, because of the architecture that it has implicit data parallelism and fault tolerance, right? So automatically will partition the work across the different worker nodes, and then it has automatic fault tolerance. So if a node goes down, it doesn't get used anymore. Another node can pick up the work, right? And this is built for you inside Spark. You don't have to manage this yourself. It has multiple programming interfaces, which is a big selling feature of Spark. Most people that I know use Python, but there's a huge community online of people that like to use Scala. There's Java as well. Even Microsoft has developed a um, .NET C Sharp interface for Spark as well, so you can do C Sharp to communicate with Spark. um, or you can use SQL. It's great. It has really strong Spark, especially has really strong SQL support. So the SQL language, and we'll see in the demos. Most of you probably already know SQL, so it should be pretty easy to pick it up, right? And then finally, because it has all this support for all these different programming interfaces, there's thousands and thousands and thousands of libraries that you can use and bring into your cluster to run packages, um, because um, there's just so many languages supported, and you can bring them into Spark, and Spark allows you to run that code against the data that you're bringing, that you're pulling out of storage. Now, something that is a little bit intimidating for a lot of people is that there is different flavors of Spark. So there's a lot of different ways to actually run what we call Spark. So there is the core package, the open source Apache Spark. I rarely see people running the open source Apache Spark. Another thing I'm going to mention now is that you can run Apache Spark on-prem if you wanted to. I rarely see nowadays people running a system like a Spark analytics system like this on premises anymore. I think somebody needs to mute. I can hear somebody talking on the background. Um, Thank you. All right, and the vast majority of people are doing this in the cloud nowadays. Huge advantage to doing it in the cloud, right? Because if you're gonna be using a system, a distributed system like Spark, you need a multiple nodes. If you're doing it on-prem, you need to manage it yourself, whether on VMs or using containers. You need to also manage the storage that you're gonna use by Spark and so on. Whereas in the cloud, these are all turnkey solutions, right? So we have open source Apache Spark, and the vendors, like Microsoft in this case, for example, add their own customizations inside their services, right? So Synapse Analytics, which we will use for most of the demos, is uses the open source Apache Spark, and then behind the scenes, Microsoft has added a little bit of utilities. It has added some performance optimization so that the Spark, they say Spark runs faster if you run the Synapse Analytics version, but the code remains mostly the same. Now, there's another vendor very popular called Cloudera. Maybe some of you have heard about it. They acquired another company called Hortonworks that used to do the only Spark distribution that ran on Windows. But now, Hortonworks is part of Cloudera, has been merged into Cloudera. So we only have Cloudera. You can run Cloudera on-prem. I think Cloudera also offers flavor in the cloud, though, to be honest, I've been doing Spark projects probably over the last 5 or 6 years. I don't see Cloudera as much. I see a lot more lately of this last one called Databricks. Databricks is a cloud-only Spark. So you can't run Databricks on-prem. Databricks runs on AWS, Azure, or Google Cloud, and it is a fully managed Spark solution. It adds a bunch of new stuff to Spark as well that is proprietary. So some of the Databricks stuff that you would write, the code would not run back on the open source Apache Spark. So that's something to keep in mind. However, for a lot of people, they're okay with this, and they just like to leverage the integrated capabilities of the Databricks environment. And I'll show Databricks as well in the demo, just to give you an idea of why, why people care about Databricks and all the stuff that Databricks offers, which is a lot. And in terms of why, why do SQL pros should care about Spark, is that before it was really, I felt, and this was something that I felt myself, is that before it was really complicated to deploy Spark. So, if I wanted to learn Spark, it's like, okay, so how do I run it? First, okay, maybe I can just run it on my laptop with a bunch of VMs, or run it on my laptop with a bunch of containers. And now I have to configure it to use my laptop storage and stuff like that. Like it was a lot more work to just get up and going. Even to do it on production grade on-prem, it would be even more work. Now in the cloud, it's really made the deployment of Spark really easy. So to me, that's an incentive for A, people to learn it, and B, for companies to adopt it too, right? It's a lot easier to get going. The SQL support that it has makes it really easy to get up and running if all you know is SQL. Another little note here is not there on the slide, but I also feel Python is pretty easy language to learn, right? It does it's not really strongly typed. It does a lot of automatic conversions for you. It does memory management, of course. Like you don't have to deal with pointers or anything like that. And so I find Python pretty easy to pick up by people in general. That's not even just SQL pros. I find Python is really easy to pick up by anybody because of all the goodies in the language and the things it does for you. So usually I tell people, if you come from a SQL background, take advantage of the SQL support that's already inside Spark, and on the side, learn some Python, right? And there's so many resources online, by the way. People ask me this all the time too, like where do I learn Python? I mean, there's great stuff that you can find for free, and there's also great material that you can pay for, right? You can go to like some of these paid learning websites, and there's a lot of really good Python learning courses. The other thing is that Spark has this thing called the structured APIs. And the idea here is to read data from storage and basically schematize it, right? And make it so that it looks more structured. So this makes the output very familiar to database people, right? Because they can think about this in the terms of, okay, I'm gonna read something from storage, I'm gonna massage it with Spark, and then it's gonna give me a table to work with, right? So they make it very familiar for database people to work with these structured APIs. And then Spark provides that ramp into what we call big data, to be able to say, I know how to work with big data systems, and the other point, right, to other programming languages like Python, like I just mentioned. And that's it. So let's just go through the demo. So I'm going to show you guys both Databricks and Synapse Analytics. We're going to look at Spark specifically inside Synapse Analytics, and then we'll jump back to see if there's some questions, and we'll wrap it up then. All right. So try to make this as interactive as possible. So let me go back into, hopefully you guys can see my screen. Yeah, let me hide this. So this is Databricks. Right now I'm logged into Databricks. And the first thing to notice with Databricks is a pretty massive product actually. So it is technically all built on top of Spark, but they have added a lot of different things to it. And the first thing that Databricks has is Databricks has three different use cases or focuses. First one is data science and engineering, which is all about running notebooks against the data. Then Databricks, also, this is a thing that Databricks has integrated as well to compete with, like in Azure, you have Azure ML, and you have also Synapse Analytics. So Databricks also has ML functionalities built in. And the idea here is that you can train your experiments, you can evaluate them, you can version them all inside Databricks too. And then finally, Databricks actually introduced, I think it was last year, Databricks introduced an experience that is 100% for writing SQL, right? So in case you are just looking to query what's already there on Databricks or what is already there in your data lake, and you're not interested in really doing data science or engineering in, like, using Python, Java, or Scala, and you just want to do SQL, then they have an optimized experience just for running SQL. Okay. You can see the Databricks workspace is, you can go in and then you can select different notebooks that you open once you have your notebooks. If you've never played around with anything like this, you probably, most of you have by this point, but if you haven't, then you have your notebooks. Notebooks are basically like pages, interactive pages that you can execute code on. They have markdown cells so that you can, put commands, you can embed images and icons and whatnot. And then you have your code cells. And in your code cells, you have the actual code that you want to execute, right? And if you see here, for example, where it says drop table if exists, create a table using CSV with these options, find it from this path. All this is very friendly SQL-like syntax that a SQL database DBA or developer could really easily pick up. And you can see here, there's different languages supported by the notebooks as well to make it the default language of the notebook, whether it's Python, SQL, Scala, or R in the case of Databricks. And I'll show you what this looks like on Synapse in a minute. So the other thing that Databricks does really well is that Databricks gives you a lot of options for how you build your Spark clusters. So I can go here and say create compute, and you'll see here there's a lot of different runtimes that I can select from for Spark. And there's a lot of different machine types. This is a big contrast to Synapse. I'll show you in a second. So if you see here, I have all these, there's 44 more, huh? So you can see here, I have all these different machines that I can select from to create my Spark cluster. Now, this is depending on who you are and what you want to do. This can be a good thing or this can be a bad thing, right? Some people would like to have less options and not have to decide amongst all these different types of machines. Other people want to have, you know, all the control in the world and really be really specific about their version of the runtime that they want to have and the type of machine that they want to run, right? So again, the focus on Databricks. Databricks is 100% Spark focused product, so they give you huge amount of capability to select the version of Spark that you want to run and to select the type of machine that you want to run as well. And then in Spark, you can create all-purpose compute, which means you're going to run jobs, you're going to run notebooks. You can create dedicated compute just for jobs. You can create pools, which basically means you create certain VMs that can be shared across clusters for automatic scaling and stuff like that. That's called a pool. And there's other things that Spark can do. For example, you can create jobs, right? They call this the workflow. So you can have jobs inside Databricks as well, in case, for example, you want to do a transformation every day at a certain amount of time, or you want to load some data into a Spark table every night and stuff like that, more to support the ETL functionality of using Spark, right? And like I said before, it has machine learning and also SQL capabilities all built into this environment. Now, I'm going to move over to Synapse. I don't know if for the people that haven't used Synapse, I'm just going to do a quick Synapse rundown, and then I'm going to go straight into the actual Spark part. So first I'm going to do is, it takes a couple of minutes to spin up a Spark cluster. If you run a cell inside a notebook in Synapse, it will do this automatically for you. So I'm just going to run this cell right now. Just run it again. There. Now it's starting this Apache Spark session. And it'll say here, please wait a few minutes while your session starts. So that's what I do at the beginning. So this will start, this will wake up the cluster while I give you just the tour of Synapse Analytics. So Synapse is not just a Spark product, right? Unlike Databricks. So you'll find Synapse has other stuff, right? So if we go, for example, into Manage, Synapse has SQL pools. This is the MPP SQL server, the distributed SQL server that used to be called Azure SQL Data Warehouse. And it also has Apache Spark pools, right? And this is the Spark part of Synapse. So Synapse is not just 100% Spark product like Databricks is, for example. This is reflected in the options too, right? So if I want to create a new Spark cluster, for example, in Synapse, You can see I have two families of nodes, and then the sizes are very standard. They're t-shirt size. You don't get the, 100 different models of VMs that you can select from like you do in Databricks. Now this again might be good for you, might be bad for you, depending on what you're looking to do, right? So Synapse offers a small, medium, large, extra large, and double extra large. When you're at double extra large, you're using nodes that have 64 cores and almost half a terabyte of memory, right? And imagine this, if I go extra large, just for fun, and all the way to max. I can go up to, by the way, this I don't think it lets you do it on the portal. I think to actually do a Synapse cluster that is 200 nodes with 64 cores and half a terabyte of memory each, I think you have to call support. Um, so I don't think this is actually, when I review and create, it's not going to let me create it. I'm not going to try to do it anyway, because if I do and it does work, in 2 minutes, it's going to run out my entire subscription. But you guys get the idea, right? So there's a lot of compute power you can get regardless here, right? So if we do the math, right, we're looking at 200 nodes with this config, then we're talking about more than 1200, no, more than 1200, no, more than 12,000 cores, right? We're looking at more than 12,000 cores and almost 100, close to 100 terabytes of memory, right? So there is a lot of horsepower here, even though you only get a few different type of nodes to select from. Once you put together this, the amount of nodes that you can put into the full cluster is a lot. Obviously, not a lot of people in the world actually will run a configuration like this, right? So I'm gonna cancel it. I want to do this card. um, and I'll just show you the one I do have, which is a memory optimized, just using a small, which is 4 vcores, 32 gigs of RAM per node, 5 nodes, and something else I wanted to show here is here. So Synapse, same as Databricks, also allows for automatic pausing, which is really nice, because it means, if you stop using your Spark cluster, you don't have to worry about, oh my God, I have to go pause it or stuff like that. It'll automatically go to sleep after a while. Let me see, for example, I have mine set to enable 30 minutes of being idle. It'll go back to sleep. So pretty cool little cost control kind of feature. And if I go back to develop, let me close this. Let's go here. Oh, it looks like the cluster is still spinning up. All right, so I'll show you guys something else in the meantime while this is still spinning up. The other thing here that Synapse does have, I was gonna go over it later, but we might as well do it now, is that Synapse, same as Databricks, Synapse allows you to have the different notebooks built into the environment too. So you can have all these different notebooks already configured, like to create in your environment. You can organize them in folders and so on. Cool thing about something that Synapse does differently from Databricks is that um, this is a tabbed interface, which I like it because it's kind of like a browser experience, right? You can open different notebooks on different tabs. Whereas Databricks is actually, you can only open, here, I'll show you guys real quick. See, if I open this notebook and then I go back, I open this notebook, it's like one at a time kind of thing, right? So that's just a little quality of life thing that I think Synapse does better. Anyway, so this is ready now. So let me close this out. Hopefully it's size of the font is pretty good for everybody to look at the screen. And let's just walk through this here. So first, again, I'm using a notebook, and you guys can see here, I'm using this percentage SQL. This basically tells the notebook engine that this cell is going to have SQL inside. And you can see the default language of my notebook is actually, it says right here, is PySpark, which is Python, right? But you can override it on a cell by cell basis, like I said, with just this, what is called the magic, which is just put a couple of percentage signs and then the different language that you want to support. So first thing I want to highlight here is how easy. Again, I just want to show it's easy for SQL pros to get going with Spark, to understand what Spark does, right? So create database if not exists. Easy. Set the database as the context that we're going to use for the rest of the notebook. Again, easy. It's a use command. almost exactly how you're used to RDBMSs. Inside this Spark cluster, most of the vendors also add their own utilities, like I said. So for example, you can see here Microsoft offers this thing called the MS Spark utils as well. And these different utilities then allow you to do some things easier because you are working inside the Microsoft environment, right? So it provides utilities for working with the file systems like copy, move, make folders or create folders, put, append into files, and so on, right? So most of the vendors, same as Databricks, they offer some utilities to make it easier to work with the underlying storage from Spark. So for example, if I want to look at the different files that are part of a folder in the cloud storage, I can use these utilities, and then I can look at all these different CSVs, gzip files, JSONs that I have, and so on, right? Also, similar to how you would use in an RDBMS, where you have all these functions that allow you to get information about the environment, you can do the same using these utilities. For example, here you can get the username, user ID, the workspace name, the pool name, and so on. All these, again, you can pull them by using functions like the system functions. So some of them are purely from Spark, like the core Apache Spark. Others will come from the vendor and the utilities that they provide, right? Now
So,
here's, yeah, go ahead.
so we got a question from SQR. He says that usually who manages these nodes and what and where can we find information about the environmental setup?
So who manages these nodes is in the case of, it depends how you're running Spark, right? So if you're running like a Spark on-prem, you need to have an actual admin, right? Like somebody that set up the environment will have the actual, let's say like the root access to either the container or the VM that has the Spark main node where all the configs are, and they would be the ones that can touch all this environment config stuff. Um, Here, and what I recommend to most people is to use solutions like Databricks or Synapse deploy Databricks or deploy Synapse, and you would have the access to do it. And then to actually manage that inside those products, it kind of depends on the product. So I'm just going to go quick, small detour because I don't want to run out of time either. But for example, for Synapse, Synapse has like access control stuff that you can do with RBAC, right? So you can select a group or a person from your Active Directory, and then you can assign those people different roles in the Synapse environment, right? So you can have some people that can run notebooks, but will not be allowed to, let's say, create new Spark clusters and stuff like that. And then in a managed environment, it's the same thing, like, right? You can have like different Apache configurations if you want to create like custom stuff, like custom definitions, or if you want to add packages, you can add new packages to upload into your workspace and so on, right? So um, if you are on-prem, do you have to like all this manage it yourself using the Apache Spark documentation and like, pull this. This is where a Spark specs the extra packages to be, like this is the path and so on. To me, it's too much of a pain. I feel like most companies nowadays should just use something like Databricks or Synapse and then just learn how these different admin tasks work on their different products that they're using, right? Whether it's Synapse or Databricks, right? So keeping it moving here. This right here is the meat and potatoes of Spark really is here is creating data frames. So data frames are variables that get assigned what I would say get assigned a definition or a metadata description of some data that is sitting in storage. So if you see here, very easy. I have a path here to a data lake path that has a Parquet file, right? And I say format is Parquet, and then I say Spark read load, and then I assign it to this variable, right? And then I'm just gonna I do a show of that data frame, right? And show what it does is just it's kind of like doing like a top 20, I think, is the usually the default for show is to have 20 records. And then you can see here, the job is in progress, and we can see as it is going along. I'm using 4 executors for this, 16 cores total, and then it's going to give us the results here in a sec. So you can see now 2 out of the 4 nodes have already completed this task that they have assigned. 3 out of 4, and then suddenly, there we go. We're getting the results, 4 out of 4 done. So this is the show, right? So the main idea here, of course, is how easy it is to just read, load, assign to a variable, and then once you have that data, and that the data is not in the variable itself. Like I said, the data frame is a description of the data, so that a Spark can then do something with it, right? So in this case, is okay. Well, this data frame says that we want data that is in this path, that is in this format. And so far, we're not asking to reformat anything about it, and then just show it, right? And then we get this, here. I guess, yes, it was top 20, right? Same thing you can do is, same as how I read it from Parquet, I can read it from CSVs, and the CSV parser and Spark is pretty good as well. If you don't provide any schema, it's just going to read everything like strings. You can say it has a header, say we can do a show, and we can do the print schema, right? So you can do print schema on any data frame. Notice how in the Parquet, I didn't specify the schema either. Spark just supports Parquet, and we'll figure out what the types are for Parquet. The CSVs obviously are not strongly typed because they're just text. So in the absence of any other information, Spark is just going to pull everything like strings, even though obviously these are numbers because we're human beings and we can look at them. It's just going to, in this case, we didn't specify anything, so it's just going to go over as strings. This is a show command, so as you can see, it just prints text, similar to how we can get nicer display on, let's say, something like Management Studio or Azure Data Studio. We can do a display here as well. And then we have a more rich interface, right? We can sort, or we can do this as well, sort by number, sort by the artist name. We have support for charts as well. So there is some visualization support here built into the notebook experience. Most notebooks are very similar. So if I went back into Databricks and I ran some of this in Databricks, you can see here, this is the notebook experience in Databricks. I see the table, I can sort here by one or the other. I can download as well. I can go into visualizations, right? So you see here it's table, and then download first, download everything, or add to a dashboard as well. Synapse also allows me to export. So you can see here I can export as CSVs, JSON, or XML. So very common here, and to get this more rich, just like spitting out the data as a text. Now I'm going to show you an example here how you apply schema on Python, right? So let's say we have that some information about users. You can actually specify the types, string, string, integer, strings, and just do a read load again. Same thing with the CSV. And notice we can pass in a custom separator. We can say schema, pass in this object as a Python struct, to basically say, oh, cancel. I don't know why it's leaving me to the Azure portal. Jumps out. And then it just says custom schema, and that's it, right? So we can run this as well. And notice here right now, I have the custom schema loaded on the data frame. If I go ahead and just print the schema from the data frame, you see we have now, the age, for example, is going to be an integer. And we can do a show command. And we can see we have this, correctly Spark interpreted the data, and no major issues. Now the sign-up string, for example, is a date. So same thing, because we are using Python, you can use any sort of, there's a lot of different support for conversions. If it was something that Spark itself doesn't support, you can even use Python libraries. But something like this is very simple, right? To do date conversions, for example, there's a toDate function, and you can add the format of the date, like the different tokens that are part of the date. In this case, see, for example, I'm using this format that's not super popular, which is like 3-letter abbreviations for months, then a number, and then a year. And I can just express that here as well. And notice here something interesting, right? So I create a new data frame, and I say, well, I want the data frame I had before, but add this new column called sign up date. And this one, I want it to actually be a date, right? And print the schema to verify. And then from the data frame, do a select of these two columns. And this will be the equivalent of just doing select sign up string, comma, sign up date from, but right now we can't run SQL from this because this is not a table, it's just a data frame variable. So run this, and we get the schema here, and we can see, right, the dates are successfully converted from this format into the standard date data type, right? Now, of course, we want to use Spark as an actual database system. So we have this data frame now, right, that we added. We did some of these conversions. And we can select the fields. See how this is all kind of composes, similar to object-oriented languages, right? This is Python. So the data frame dot select, the select method, we pass in the columns that we want. The return from that, we do a dot write and dot save as a table called user details. So we're going to create a new table, basically here, called user details based on the contents of the data frame. And this is the part where, at the end of the day, Spark just becomes another database that is full of tables, that is full of data, that is easy, again, to work with for SQL pros, right? And if I even go back here to the Azure, the Synapse portal, Synapse has nice support here for browsing the data. So this is a database called Music Service. And if I go here, I refresh this, we'll see now, we see that new table called user details, and we can even look at the columns, which is nice here. It's all supported here in the Synapse environment, right? JSON support is really good in Spark as well. You can see here, for example, it has multi-line support for JSON, and it'll automatically, something that's really nice about the Spark support is that it automatically will decompose your JSON into a tree so for example, if you are working with JSON data that you're not familiar with, Spark will kind of help you understand it too. So just to show you what I mean by that is I have this JSON file here, and then I do the JSON.print schema, and we can see Spark kind of like parsed the JSON file, and then it tells me, okay, so this is, you have the root of the file, which is just the file itself, and then inside it, you have this array called service users, and then this array is composed of these structs, these elements, and then these structs are composed of these different fields, age, country, gender, sign-up string, and user ID. They look like they might be this type of data. So the age, for example, immediately tells that it's a number, right? So that's kind of cool as well. And the nice thing, of course, is that Spark also supports, similar to, if you're familiar with SQL Server. I forget the name of the function in SQL Server. I think it's called OpenJSON, which you can, kind of like parse and deconstruct your JSON. So Spark can do that as well, right? So you can see here in Spark, it's called an explode. So Spark can take this array, service users, and do an explode on the service users, and then show what that looks like. So that's like drilling one level down into the JSON. And I'll show you guys here. So now we see here, right? Instead of having this hierarchical structure, now we do have one struct per row, but it's still a structure, right? It's not yet multiple columns like what we want, right? But we were able to remove one level of the hierarchy. Now it's just the users and their fields. So obviously, what do you do then? Then at that point, we just need to do a select of all those different fields out of each one of these, right? So you can see here, I just have to grab that data frame that's now in this format and then select the different columns out of it. And we basically end up with a tabular structure that we're all used to, which is nice, right? Now it has the user ID properly, the age and the country, right? So very easy to use tools to also, do the simpler stuff, like grabbing the JSON, really strong parser support for that, and then to deconstruct it and make it tabular, similar to how you would find in the bigger commercial database tools as well, right? So nothing new there. You can create views in Spark. So for example, here you can see I go into the data frame and I say create or replace it. So create or replace a view called user artist place that basically points to this data frame. Now that it is a view, I can run just bare bones SQL against it. So now see how I can just do a select start from this view, user artist place, right? Now put a limit 10 just to make it. But now we have this as a view, so we're able to run regular queries against it. It's very common for people when they're doing their own development to create these temp views, right? So that they can immediately go into being able to run select. Now, obviously, it's a temp view. So the moment this session is over, that temp view is going to go away. Another cool thing, again, this is something that it it will be part of like the data engineering process. Is sometimes you're doing some computations or whatever, and the results you want it to be saved as another table, right? So you can see here I have a spark.sql. I run this SQL, and then the results of this SQL will go into a data frame, and then I can write this data frame again as a new table, right? So this is a way to create new tables from the existing tables that we already have. A very common operation as well that we all do with RDBMSs. And again, something that we really easy to understand and pick up for people that are used from a SQL background, right? So now we have another table. If I go back into the browser, we should see the new data. Let's refresh the table list. You see, now we have that new table as well, right? Platform artist performance. Okay, and I can select from it as well, and we'll see. There we go. And we can get the data there as well, right? So there's a new table that has been computed. Now, something to keep in mind, very important. When you create a new table in Spark, what Spark is doing under the covers is that it's grabbing the result of whatever query you did to create that table, and then it creates new Parquet files and it stores it in the cloud storage that you assigned to the Spark cluster, right? Whether it's Databricks, whether it's Synapse, and so the results of these tables are like taking a snapshot. It's like taking a picture, right? If I then, we built this platform artist from this other view, and this other view was populated from this JSON file. If I then, tomorrow I go back and replace the JSON file with a new JSON file, it's not automatically going to get reflected into the table, right? Because Spark did a copy and stored it separately. And whatever changes happen to the source data, they're not going to get automatically reflected. You have to go back and rerun your process to read the file again, recalculate whatever it was that you did, and save it again as the new contents of the table. Okay. Similar to how we do in our RDBMS as well, you can do show commands to look at the different tables. You see here, I have them here. Some of them are temporary, some of them are not. You can also describe. Describe is a very popular command in other RDBMSs that are not SQL Server. And you get like the different informations, right? Oh, these are the columns. This is the detailed information about the table, where you would find it in the cloud storage, and so on, right? You can define permanent views as well, right? So I can go here, and you can see this is not a temporary view. This is a permanent view. It's a view called user details by country. And I define this this SQL statement, the select statement, to go along with the view. So a view, obviously, does not store the data, right? These are just regular views. So if the underlying table changes, then when you query the view, then yes, those will be immediate, right? The view is a view. It's not the same as like with the tables and the source files, right? If the source files change, the contents of the table itself will stay the same, because again, the table, when it was materialized, it was like taking a picture based on how the files look like at that point in time. Of course, we can select from a view. There's no problem with that. So this is really nice support for that as well. All right, we get all our information back. And the nice thing about Spark is with some research, you can process almost any file type, right? So for example, I have this folder that is full of JPEGs of music album images. And I just Googled, what support does Spark have for image processing? And then I found, PySpark has an ML package that has an image module, and you can import this thing called the image schema, and you can read images from the image schema, and then you can select all this metadata from the images. So you can see here, this is the metadata that we get from the images, the origin, height, width, end channels, mode, and the actual binary data from the image. And from my the JPEGs that I have stored there, for example, I can get the height and the width of those JPEGs, right? So with very little work, because the ecosystem is so large, you get thousands of libraries. You can process almost any file type that you can think of with Spark, right? Only thing to keep in mind in terms of how Spark operates versus an RDBMS, I want to just, yeah, we have a couple of minutes. For example, if I want to run an insert of one particular value, so that will work, right? See, jumps executed, succeeded. I can run an insert from a select, right? Which is very common, obviously, that we do that in RDBMSs all the time as well. And this will work as well. However, the core Spark implementation of tables does not support DML. So you will not be able to do an update on a Spark, like the actual open source Spark tables. You will not be able to do a delete either. You can see all this. Nope, there's no deletes here either. You'll not be able to do a delete on it. So if you are using the vanilla Spark tables, the only way to update or delete is to overwrite, right? And if you're dealing with really big tables, you don't want to overwrite the whole table. Usually what you do is that if you know that you're going to have to do updates or deletes, and you're forced to stay in the garden of the open source, pure open source Spark, then you got to partition your table. And whenever you have to do an update or a delete, what you do is you recompute the partition, and then you replace the partition, which is supported by Spark. There are other projects like I highlight here. You can Google them later. Out of the scope for the session today, we'll run out of time if we go into each of these. But there's projects like Delta Lake, Apache Iceberg, or Apache Hudi that extend Spark with more advanced table capabilities. So these projects, they're all independent projects. They're kind of all trying to do similar things, but that's kind of like how the open source space works. And they all work in a slightly different ways, but they are all trying to basically bring advanced capabilities to Spark tables. And some of them are pretty advanced. That this Delta Lake is the one that I've worked with the most. And they allow you to do things like DML, for example, right? Delete, update. They even allow you to do things like time travel on a table. So to be able to say, hey, let's select from the table as if it was yesterday kind of thing. Delta Lake allows you to do zero copy clones of tables, which is pretty cool as well for development. For example, you can do a clone of a table and let your developers work on it, and it is a zero copy operation. And what else does Delta Lake do? Oh, it also does ACID transactions against the table, which Spark doesn't do, right? So if Spark is loading data and then suddenly for whatever reason it dies, the process, then you might be left in a limbo state. Delta Lake does not. Delta Lake is ACID for operations, which is pretty cool as well. So all these extend what Spark can do. And if you are ever go into the Spark ecosystem, you will probably end up working with some of these in a production scenario, because the capabilities that they add are just too important nowadays to just stay. So for learning Spark, whatever, you can use the Spark vanilla tables, but I think for the most part, most people, once they go into production and really use Spark for data engineering and so on, they use one of these three projects. The two that I've heard and worked with the most are Delta Lake or Iceberg, but and the one that I've personally worked with the most is definitely Delta Lake. And then one last thing before we go is that Spark also has a layer of caching, but it's not automatic. Like for example, like the SQL Server buffer cache, right? You actually have to be explicit. Like for example, I read this data here, a data frame that says Spark select from user details, and I have to say, this one cache it for me, right? And this is lazy caching, so it won't actually cache it until it really has to. So once I count it, So I want to count the data, right? I just want to run count command. This is 357,921 records. Now it is cached, right? So it doesn't cache it. I don't know if you'll see. Yeah, see, it's more responsive the second time. So, but this is manually managed, and there's different persist levels. I put them here in the notebook just for reference. So you can persist only in memory, you can persist in memory without serialization, uh, sorry, with serialization, so that it uses less memory but might spend more time. It uses memory but also replicates to different nodes. So if you have like a really big data set and you want to cache it, but you're afraid that, one of the nodes might fail and then you won't be cached anymore, then you can do memory only across multiple nodes and so on. So there's multiple levels of caching that you can play with. But again, this is all manual caching. You have to be able to know what you're doing. Databricks offers an automatic cache, but it is a Databricks only feature. It is not a Spark feature. All right. So jumping back, since we only have a couple of minutes, recap. The Spark is the de facto open source big data engine used today. If you're going to go into big data engines or use want to enter the data engineering space, you will have to learn Spark. The strength in Spark is in its openness, right? In its ability to move across platforms for the most part. It is a very flexible product with the multiple languages that it supports, and obviously it has a massive amount of libraries because of that as well. And the most important thing for the audience today is that with a bit of studying and practice, I believe you can pick it up. It can be picked up by any person that has a SQL background, and then add it to your big data toolbox and say you are familiar with it and have something extra to put on your resume. All right, and I'll take a pause here and see if we have any questions.
We
Go
do,
back into the teams.
as always.
Teams.
First one is the SQL statements you showed are all well and good, but can we do like we do in SQL Server, Oracle, whatnot? Can we have store procedures or triggers?
So I don't think you can have store procedures or triggers, but this is replaced by other things, right? So in Spark, for example, if you needed something like a store proc, you could have like a job that is a saved in like Databricks or um, in Synapse, right? And then you could run the job as you run like a store proc. You can also have your own libraries that you bring in, right? So you have to, yeah, it works in a different way, right? So you have to, let's say, for example, write some Python. Let's say you have some code that you always want to execute all the time. You could write it in Python, put it in a Python library, and then import that Python library into your Spark cluster so that it's always there, right? So the intent of Spark, while the SQL support is strong, the intent of it is also not to do everything that the RDBMSs do, right? And this is something I was actually talking with Kevin before the session started, is if you're happy with your RDBMS and you don't really have this scenario where you have a bunch of data sitting in cloud storage or a bunch of data that is in files that you don't really want to spend the money for bringing into an RDBMS, then you don't really have a use case, and that's fine, right? You have to find the use case for Spark. In my opinion, the use case for Spark is you have a bunch of different files, like flat file data or unstructured data, and you don't want to bring it all into, a SQL server or an Oracle or a MySQL, or you don't really know even what you really have, and you want to enable people to be able to explore on their own, then you can put Spark on top of that and make it easier, right? If you want to replace the concept of something like store procs, then yeah, you can do it with some other things. But the SQL support, it won't be in the actual SQL language. You would develop like a Python library or Java library or something like that, right?
Yeah, that's what I was thinking. It's going to be usually done in, say, Python or some of the fun languages are out there now that everybody is starting to use that hit 10,000 other things. Cool. Let's see. think the last one we'll have time for here is, as an owner of the database, you have privileges, but somebody that does not have the admin privileges,
Let me see. As an owner, you have all the privilege, but somebody will have to be the admin because everybody can create everything. Very soon will be Oh yeah, 100%. 100%. You need an admin. That's what I just showed in the screen there, the Synapse Analytics. You can have different roles for it. There's people that will be allowed to create clusters, for example, or to create new things in storage. And there's other people that will just have access to execute the notebooks, right? But that layer is because of the way the Spark works. If you were using like just a basic core Apache Spark, it doesn't really have a layer for fine-grained control. This is where the commercial part comes in. So either you use Databricks or you use Synapse or you use Cloudera. They all have like their own way of doing the fine-grained control, right? And then how you do it will depend on which one you're using. Yeah. Okay.
cool. I think that covers us. Thank you so much for this, Warner. This has been awesome.
Absolutely. I appreciate the time. Thank you, everybody, for joining me today. Until next time, thanks for watching.
Thanks, y'all. This
Bye.
will be available here rather soon, so on our website and on YouTube. So please be sure to catch us there.